All right, let's take a look at worksheet 13.2 dealing with normal distributions. So on the first problem it says the distribution of weights of 9-ounce bags of a particular brand of potato chips are approximately normal with a mean of 9.12 ounces and a standard deviation of 0.05 ounces. So in part A it asks you to sketch a normal curve labeling the mean and approximately one standard deviation away from the mean would be. So, sketch myself an x-axis, draw myself a nice normal curve. The mean is right at the peak, 9.12 ounces. Now I go to approximately where the inflection points would be, where it changes curvature approximately, and I add 0.05 ounces, so that would go up to 9.17. And if I subtract, I get 9.07 ounces. So that's all you need to do in part A. Part B then asks you if you were to graph it on your calculator, what would you enter in your calculator, including your window? So remember, when we graph this on our graphing calculator, we're going to go into the y equals and go normal PDF. We enter in the variable x, we enter in the mean, and we enter in the standard deviation. So again, this value is your mean, and this is your standard deviation. So, to show you how to enter that in your calculator, I'll do that in just a second, but I want to get the window for us. So to get the window, what we want to do is we want to take the mean minus 3 standard deviations, the mean plus 3 standard deviations. So if you continue to add and subtract 0.05s, the minimum will be 8.97, your maximum will be 9.27, your y min, this is just an always, so that it shows up nicely, make it negative 0.02. For your y max, what you want to do is take the number 0.4 and divide it by the standard deviation. So in this case, 0.4 divided by 0.05, we're going to make our y max approximately 8. So now, just to show the graph on our graphing calculator. So, if I go to my y equals, I want to make sure I'm in the y1 form. If your calculator is still in sequential mode, go to mode, make sure it's in the function mode. So if you go down here, you can see that it says highlighted function. Make sure you change that. So if I go back to the y equals, I want to select normal PDF. So if I go second vars, there it is, number 1. I type in the x, I type in the mean, 9.12, and I type in the standard deviation, 0.05. Go ahead and close it. Then, instead of hitting graph, if I go ahead and hit graph, it'll probably say invalid dim, or it might not show up. That means I need to quit and go to my window and change my window appropriately. As you can see, thy values are totally different based on a different problem. That's where you type in the 8.97 for your min. For your max, you're going to put 9.27. Keep your scale at 1. Your y min, you type in at negative 0.02. And your y max, in this case, was 8. Keep your scale at 1. So now when you hit the graph, I'm still getting invalid dim. My guess is this. If this is still happening to you like it is to me, go second y equals, and sure enough, look, I have a stat plot that is on. Select number 4 where it says stat plots off. It's going to do it. Now if I hit graph, lo and behold, my normal curve shows up. The stat plot issue is that you have a stat plot on and there's no data in your calculator. Okay? So moving right along to question C. So we look at question C. Whoa, jumped too far again on me. Question C says, find the proportion of bags of potato chips that are between 9.1 and 9.2 ounces. Note what you entered in your calculator. So on all of these, we're actually going to use the calculator. So in this case, we do normal CDF because we want to find that area. We do the lower bound, 9.1, to the upper bound, 9.2, because I want to do between 9.1 and 9.2. Enter in my mean, and then my standard deviation. Again, this is the lower bound score, the upper bound score, the mean, and the standard deviation. So to get normal, sorry, I forgot the AL there, normal CDF on your calculator, again, what you want to hit is second vars, and then in this case, it's number 2. So, I show you how to type this one in real quick on your calculator. If you go second vars, normal CDF, then I can go 9.1, comma 9.2, comma 9.12, comma 0.05. Close my parenthesis, go ahead and hit enter, and it gives me that proportion as 0.6006. Again, with our proportions, we want to go out 4 decimal places. Alright, D, same process, just a different question. So it says, find the proportion of bags of potato chips that are underweight, less than 9 ounces. So I'm going to do normal CDF again, but if I think about less than 9 ounces, I want to go from basically 0 to 9. I don't have to put any negatives because you can't have a negative bag of chips, doesn't make any sense. So I'm going to go from 0 to 9, 9.12, 0.05. And I'm going to enter this into my calculator. So, again, second vars, normal CDF, goes 0, comma, 9, comma, 9.12, comma, 0.05. Close my parenthesis, hit enter, and there I have it at 0.0082. Alright, last one on this page. So now it says find all the potato chips, or the proportion of potato chips that are more than 9.25 ounces. So, normal CDF. Now I'm looking at going at 9.25 to as big as possible. Well, this next number, you just need to make sure you pick a number that, is big enough to incorporate all of them. I usually use 100 or, I look at the context of the problem. It wouldn't make any sense to see a bag of potato chips more than 100 ounces. Should be able to get all of the possibilities. So I can go ahead and type this into my calculator. So again, I'm just going to hit clear for a second. Second vars, number 2. So in this case, I'm going from 9.25 to a very large number. I chose 100. You could choose 90 and it'll probably give you the same exact answer. 9.12, comma, 0.05. Go ahead and hit enter, and it gives me 0.0047. Okay. Let's move on to the second page. This video, we're trying to just do it all at once since it's the similar types of problems. So, on number 2, it says the distributional weights of 20-ounce water bottles made by local beverage companies are approximately normal with a mean of 20.09 ounces and a standard deviation of 0.04 ounces. So again, just like you did on number 1, sketch a normal curve, labeling the mean. So there's my normal curve, the mean, 20.09 ounces, and 1 standard deviation to the right, so 20.13, and to the left, 20.05. So now, we want to put into our calculator to be able to graph it. So I would go normal PDF, X, comma, 20.09, comma, 0.04. So now to get the x min, again you take mean minus 3 times the standard deviations. So 19.97. And then the mean plus 3 standard deviations to get above the mean, which would be 20.21. Your y min is always negative 0.02 just because we want that graph to show up above the bottom of the graph. And then 0.4 divided by 0.04 is equal to 10. So if you want to see the graph again, we can type that into my y equals. So if you go to y equals, if I go second vars, normal PDF, so I want to type in x, comma, 20.09, comma, 0.04, close my parenthesis. Now I got to go to my window, change my window here, so it shows up 19.97 to 20.21. Keep that scale at 1. Y min doesn't change. The 8 now goes to 10. Now when I hit graph, sure enough, it fits in there nice and neat. Alright, let's move right along to the last 3 problems on this page, similar to what they were on the other side. So, first one says, find the proportion of water bottles between 19.98 and 20.15 ounces. Note what you entered in your calculator. So all of these problems are going to involve normal CDF. Again, we go a lower bound. We want to go from 19.98 to 20.15 with a mean of 20.09 and a standard deviation of 0.05. So, if we enter that into our calculator, clear, second vars, number 2 gives me my normal CDF. So I'm going to type in 19.98, comma, 20.15, comma, 20.09, comma, 0.04. Close my parenthesis, hit enter, and there we go. The proportion of water bottles is 0.9302. Letter D, same process. We want to find the proportion of water bottles that are underweight, less than 20 ounces. So basically, how many bottles are we selling that are less than what we advertise? So, we can go from 0 to 20. 20.15 was our mean, 20.09, was our mean. And my standard deviation was 0.05. So, go ahead and enter this again into our calculator. So second vars, number 2, normal CDF, 0, 20, 20.09, 0.04. Close parenthesis, and whoa, I see I must have had a little typo there. I had 0.20, I'm going to try that again. So second vars, number 2, so it should have gone 0, I think it missed a comma there, 20, 20.09, 0.04. Close my parenthesis, hit enter, let's see if we get it this time. Yep, 0.0122. Alright, our last one here, it says find the proportion of water bottles that weigh more than 20.2 ounces. Again, let's note what we enter in here. So normal CDF, so we want more than 20.2 ounces. So now we just have to figure out a number to go that's big enough. I'll stick with my 100, that's going to be plenty. You could probably put in 25 and get the exact same answer. So, let's check it out. Second vars, normal CDF, 20.2, to I did 100, 20.09, comma, 0.04. Close parentheses. Go ahead and hit enter. 0.00297, which would round to 0.0030. All right, that ends this particular worksheet.